So now you see, this is the pilot test. In fact, is conducted initial load test. Here you see, for this one residential project, here you see, this is actually codal provision as per IS 2911. Now 2014 it was revised. The safe vertical compression load on pile is the least of these two things. The first one is 2/3 of the load corresponding to 12 mm settlement. Second one, design load. So the lesser of two values is used to consider. So now you see, this is the piles they are constructed. In fact, they are underrimmed pile foundations. You can see this is one housing board colony in our Vijayawada. You know, you can know Bhavanipuram APHB colony. So you see, here you see, this is the Kentledge. I can pick the pen. Yes, this is the Kentledge. You can see. So they are just sandbags. Here we have sheet piles. This is sheet actually. And also we have gutters here, small gutters. But you can see the main gutter here. This is used for reaction gutter, for getting reaction. So this is the actually ISMB 450. This one, you see, this is the main gutter. So anyhow, here you can see this is the hydraulic jock. So which use it for applying load, and this is the pile actually. We have kept one plate over this pile, and you can see this dial gauge. So to measure the settlement, so we are applying the load now. So let me show you. This is for Burj Dubai. Somebody say that, you see. This is Burj Dubai. The beauty here you see, Burj Dubai. Here you see the jacks they are used is, you may be shocked, 1,500 tons. So you see, they are specially designed actually. They are specially designed. See how much load they are applying. Just imagine. So just one jack is 1,500 tons. 1,500 tons. Just imagine, this jack will lift more than a 10-story building. So just imagine now, 1,500 tons. So like that, you see how many jocks are there. This is the pile actually. In fact, this is Burj Dubai. Don't worry. So now we will come to our story. Ours is a small one. So these are the dial gauges. So this is a jack we are using. So now this is a reactant gutter. Once you are lifting the jack with pressure, so we will apply the pressure where we will have pressure gauge. From that we can get kg per centimeter square into area of the ram. Then it becomes load. Now the thing is, here you see, these are the dial gauges used for measuring settlement. So now you can see here, this is the what I say, load we are applied, and these are the dial gauge readings. You can see only 2 dial gauges are used. Better to use 4 dial gauges on all the sides, on all the 4 sides. So now you can see we have a load settlement curve. I will show you. This is load settlement curve. But the fact is, you see, we have not touched 12 mm settlement. We just stopped at 55 tons. Maybe you see, meeru comment cheyochu. A day will come, you will comment us. So the thing is, 55. We just actually applied the load. The design load is here. It is 30 tons. In fact, you see, we applied the load up to 57.6, because you see, our Kentledge is very small. Our loading is very small, 57 tons only. This is the practical limitation actually. When you are working, so putting a lot of load is required, and we have to test the load. We have to apply the load gradually. Actually, you may ask, now I am coming to the codal provision. Anyhow, we have our own limitation. So you got this idea how we are transferring dial gauge reading into settlement, multiplying with 0.01, because the least count of the dial gauge is 0.01, then it is in millimeter. Make the average and you will get the settlement. So in fact, actually, I will show you. So what code is saying. Here you see. Now you see, The today's discussion is about pilot test. Here you can see this is sandbags. In fact, this is called Kentridge. And we have anchor, here you see anchor gudder. This is the reaction gudder. And we have hydraulic jack. And now you see this is the test pile. Actually, we are used to call two things here. There are two types of pilot test. One is initial test, another one is routine test. Initial test means we use it to conduct pilot test on test pile. Test pile. That means that pile you are not going to use except for testing. Whereas routine test means the load, after completion of the load test, you will use the same pile for taking care about structural, to carry the structural load. So that's, you will not leave that pile. You will use that pile for carrying the load. That is what I call routine test. So here initial test means it is only for testing. It is only for testing. Here you see, I can tell you we are applying the load in gradually. That means in increments. So in fact, how you will apply the load? So the first load Q1. So we use it to apply the load in increments. So 1/5 of estimated safe load. 1/5 of estimated safe load. See, you may ask, sir, how I am getting estimated safe load? We discussed clearly how to calculate estimated safe load. QS is equal to QU by factor of safety. QU means QP plus QS. We have done all this study. So don't apply the load all of a sudden. Apply the load gradually. So now in the first is, sometimes you see, I'm telling 1/5. Somebody is studying one book, he's saying that 20% of the estimated safe load. See, in fact, you see 1/5 is 0.2. 1/5 is 0.2, nothing but 20%. So apply the load in increments. So now you see, so actually the test is conducted, here you see, about 20% of the load is applied in equal increments. If you see Q2, again Q2 is obviously Q1 plus now 1/5 of estimated safe load. So this is second because we already applied first one. Now Q3 is obviously, again we will add 1/5 of estimated safe load. We use it to measure the settlement in the regular time intervals. So now we are getting, see, in fact, you see the load is what I say, removed in the same decrements at 1 hour interval, and the final rebound is recorded. Sometimes you see we measure the rebound, what I say, rebound. So after reloading, unloading, after unloading, we can get the rebound. So now you can see net settlement is equal to total settlement minus elastic rebound. So now the graph is plot between load and settlement. Load and settlement. Draw the plot. It must be, see, this is settlement, this is load. P delta curve. Now you see how you are determining the safe load. Here you see, plot the load settlement curve and estimate the allowable load as per. You see 2/3. I already mentioned 2/3 of the load corresponding to 12 mm settlement. So here luckily we can pick up the 12 mm because the test is conducted up to 30 mm. So they have that capacity. That means they are ready to wait, and they have, what I say, they have that much, what I say, that much load they can put it. So they have their understanding. Here you see 2/3 of the load corresponding to 12 mm. Here you see the load corresponding, after drawing the plot, we can get load corresponding to 12 mm, which is 520, Here you see 520 kilonewton. So 2/3 of 520, I have the answer here, 343. So I have 34 tons. This is one. Now second one, 50% of the load causing total settlement equal to 10% of the pile diameter. So here you see the diameter of the pile is 300. Now 10% of the pile diameter is obviously 30 mm. So I have 30 mm. The load corresponding to 30 mm is, here you see, 600 kilonewton. So 50% of the load corresponding to settlement equal to 10% of pile diameter. So 300 kilonewton. So now the lesser of 1 and 2, lesser of 1 and 2 is reported as allowable load carrying capacity of the pile. Allowable load carrying capacity of the pile. So I can tell you once again, how you will decide allowable load carrying capacity of the pile is based on this criteria. So we have two observations. One is 2/3 of the load corresponding to 12 mm settlement. First, to draw the load settlement curve. So now try to pick up the value. Now try to pick up the load corresponding to 12 mm settlement. Here in this picture, see, I have an observation. Load on pile, kilonewton, and the settlement is given. So now you see, I can able to trace the value corresponding to 12 mm by plotting this load settlement curve. Fortunately, the load corresponding to 12 mm settlement in this particular situation is 520 kilonewton. 2 by 3 into 520 is 343.2 kilonewton. Now you see, the second condition is 50% of the load corresponding to settlement, which is equal to 10% of the pile diameter. 10% of the, here you see, I have 10%. Here you see 10%. The pile diameter of the pile is 300 mm. 10% of D is 30 mm. Now you see, the load corresponding to 30 mm is 600 kilonewton. So now you see 1 by 2, 50%. 1 by 2 into 600 kilonewton. So 300 kilonewton. Now the safe load is lesser of 1 and 2. Lesser of 1 and 2. This is what code is saying. IS 29.